Okay, so let's try to study this problem, maximum length of repeated subarray. So the problem said given two arrays, okay, and we need to find the length of the maximum length of the repeated subarray. So subarray means this is 3 to 1 and over here 3 to 1, okay. So 3 to 1, 3 to 1. So what is the maximum length? So maximum length is 3. So we need to return 3, okay. Now prerequisite to this problem is longest common subsequence. If you have not watched that, I would highly recommend, like before coming to this problem, you watch that longest common subsequence lecture for the longest common subsequence, okay. And this problem is also similar, very similar to finding longest common substring, okay. So if we both, the problem is same almost, right, okay. So so let's try to draw the table like whatever we did in the LCS problem, okay. So you have 3 2 1 4 7, okay, and on the left we have 1 2 3 2 1, okay. Okay, and what we did, we last row and last column we initialize with 0, right. Zero 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 zero. Okay, let's try to find what is longest between 1 4 7 and 1, okay. So let's try this cell, okay. So 1 4 7 and 1, okay. So what is the maximum length? So what is common over here? So we got 1, okay, only 1 we got, okay. Now let's try to find 2 1 4 7 and 2 1. So for this and for this, okay. So this cell, so what is the longest? So it is 2, okay. So what we are basically doing, so if it is, we are just taking the first number of both the subarrays, okay, first number of both the subarrays. So if the first number of both the subarrays are same, then we are adding 1 to it, okay. So over here what we are doing, so we are diagonally adding the value, diagonally summing up, diagonally adding. So if you had 1 over here, then we are adding 1 over here, and then we are able to get 2 over here. In the LCS problem, what we are doing, so if we had two cases, right. If both the letters of both the substring of the string are same, then what we are doing, we are adding 1, and then we are doing f of index minus 1, index minus 1, or index plus 1 and index plus 2, index plus 1 and index 2, index 1 plus 1 and index 2 plus 1, okay. But over, and if it was not same, then what we are doing, if we are doing the maximum of these two, right, these two cells, but over it's not needed, right, because we need to find, we are not here to find the subsequence, we are to find the substring or sub array over here, okay. So in that case, that particular case, we can simply ignore over here, and simply we can follow the approach like if the letters or if the numbers of both the subarrays are same, then we can add 1 and move for the next index or the next subarray, okay. Okay, so let's try to code this up. So as we did before, so if in the LCS problem, same thing we can swap, like we can swap if length of nums1 is greater than length of nums2, then we can swap nums1 with nums2, so it will be nums2 and this is nums1, okay. Then we'll get the length of nums1 and would be length of nums2, Okay, so if you have understood the LCS, like longest common subsequence statement, this will be very easy. Then we'll declare a variable to store the max length. So max length is 0. We can assign 0. Then we'll declare a dp table. Dp table, this will return initialize with 0. So inner table size would be n plus 1 for item in range m plus 1. Okay, so this is this is fine, this is fine. Okay, next we'll run two loops. One will start from m minus 1, another will start from n minus 1. So for I in range m minus 1 minus 1 minus 1, for j in range n minus 1 minus 1 minus 1. Okay, next we'll check whether the first number is same. Okay, so if s1 sorry if nums1 first case, so first case a nums1 of I is equal to nums2 of j. Okay, then what we did in the LCS problem, we did dp of I is equal to, we added 1 and then moved to the so basically we calculated the value of the diagonal row. So this is the diagonal row and we added 1. So this is the diagonal row. Okay, so this is the diagonal row and then we added 1 over here. Okay, so if it is, if the both the nums1 and nums2, the first letter, first number in both the nums array are same. Okay, then what we did, if they are not same, then what we did, and before that we can assign and calculate the max length over here, because we got some length over here. So then what we can do, so we can do maximum length and the current dp of ij. Okay, so this dp of ij. Okay, now over here else dp of ij you can assign 0, because the first number are not same. So this is the change basically. In the LCS problem we try to find the all the maximum of the two subsequences. Okay, so but over here we are not interested, so we can just simply we can simply assign 0 over here. Okay, so then finally we can return max length. Okay, hope everything is good over here. This is 0 1 range in minus 1 dp of 1 plus max length else. Okay, all right, it is passing. Passing as well. So what will be the time complexity for this? So time complexity would be O of m into n, because we are running two loops over here. Space complexity would be O of m into n. Okay, can we improve the space complexity? This is current row and we are just referring the diagonal row over here. So diagonal row. Okay, so diagonal row. So if you can store the diagonal row, then we are good, right? So what we can do, so we can declare this we can change to previous. Okay, so we are just needing, and this would be 0 n minus 1 and this is fine, and then we can declare another 1D array, same. Okay, now this will remain same, this will become current, this will become previous, because we are preparing the diagonal row. previous of j plus 1, this should become current. Okay, this should become current. Okay, and once the inner loop ends, we can switch previous is equal to current. Okay, and so this is fine, current. Okay, so hope you are good. Okay, if we submit this, hope it will pass. Okay, what will be the time complexity for this? So time complexity will remain same, but this should become, rather than using two 1D two 2D DP array, so we are using one 1D array, so it will be O of 2n, or you can say O of n. Okay.